Okay, guys. So a very good morning to all of you once again. So today, basically, in the from the last 3-4 lectures, we were discussing about uh, the metal cutting operations, basics of the metal cutting, and the fundamentals of manufacturing processes. And last in the last lecture, we discussed about the relationship that is between the R phi and alpha, that is chip thickness ratio, phi which is a shear angle, and R that alpha that is a rake angle. Okay, so that we gone through, and we also see the relationship between VC, and Vs. That is the cutting velocity, chip velocity, and the shear velocity respectively. So today we are going to discuss about the last. You should consider this last lecture for this unit as well. Okay, and the two more lectures that I will share with you guys, which is based on the unit number 5. Okay, that is additive manufacturing. So if I will get the time, then I will share the notes, video lectures of building processes as well. But as I said previously that up to 20 only I will take officially these classes. Okay, I will send the recorded lecture. So you should consider up to 20 only. Okay. So this is before going to start this tool signature and the geometry of a single point cutting tool. Uh, I just want to discuss one of the problem that is related with the relationship between VC, and Vs. Okay. So the rake angle of the cutting tool, rake angle means alpha, okay, of a cutting tool is 15 degree. Once alpha is given to you, that is 15 degree. The shear angle is 45 degree, that is phi is given to you. Okay, the cutting velocity is 35 mpm, that is mpm is nothing but that is meter per minute. Okay, and which is cutting velocity, which is v is given to you. Okay, what is the velocity of chip along with the tool face? Okay, so why it is mentioned that along with the tool face, because this is the tool face. Okay, if we are moving this tool like that, then this is the tool face. Okay, this is the rig face, and when the chip is coming out, it is moving like that. Okay, so this is the, along with that, the chip velocity is there. Okay, so we have to find out the velocity of vc, means sorry, the value of vc. Okay, so now we know the relationship that we saw in the last time, that is v upon cos phi minus alpha equals to vc upon sin phi equals to vs upon cos of alpha. Please let me know if I am wrong. Okay, guys. So here this phi, that is shear angle, is given to you. Alpha rake angle is given to you. V is given to you, that is cutting velocity. We have to calculate the value of vc. From here we can use these two relationship. So here the value of v will be equals to, that is 35 mpm upon cos of phi. Phi is given to you, that is 45 degree, minus alpha, that is 15 degree. Okay, equals to vc. We have to calculate, and sin phi. Phi is again 45. So can you tell me the value of vc from here? I'm also calculating. I will not tell first answer. You have to tell, right, Monisha? This 28.57, right? Very good. This is option A, right? This is 28.57. This is mpm, that is meter per minute. Sorry, mpm. Okay, that is meter per minute, and the option will be A. Fine. So this is the simple problem. And by the way, you can also calculate the value of Vs from here, and you can tell me later on. Okay. So let's move to the today's main topic, which is the tool signature and the geometry of a single point cutting tool. So okay, so before okay, I just want to write the topic that I just want to write the tool signature, that what type of the tool signatures are available. So generally two, or sometimes also like we say three tool signatures. Okay, so if we go as per the foreign author books, then they call it as a two only. Okay, but if we go to the Indian authors, then they call it as a, there is a different, that is three. Okay, so first is as per the tool signature, I will tell you what is the meaning of that. First is like American Standard Association. American Standard Association. Association. Okay, that is ASA system. We are calling it as a ASA system. Second is the orthogonal rake system. Orthogonal rake system, ORS. Okay, and if we'll go through the Indian authors, then they mention that is normal rake system. Normal rake system, that is NRS. Okay, so what terminology we have to use here, that I will discuss later on. First of all, we should go through this the geometry of a single point cutting tool. Okay, so for that, as I said, that I'm using this rubber. Okay, and let's discuss first. Okay, fine. So this is a basically what we are doing is here we are creating a single point a model of a single point cutting tool, that how a single point cutting tool is looks like. Okay, so initially this tools basically is prepared from the material only, or we can say like billet only. Okay, so billet is what? Billet is like whatever a rectangle cross section we have initially, or square cross section blooms, we can say blooms or billets, through which we can go through this, we can prepare these single point cutting tool. So here we are similarly we are using like this is the length of this rubber. Okay, we are just making this single point cutting tool with this rubber. Okay, so this is the length, this is the cross sectional area. Okay, and this is the thickness. Okay, so here I am mentioning here that this is this portion I am starting from this one. So this is my front. Okay, this is my front. F is I have written over there F, and this is basically and. Okay, means I'm wherever this is and I have written. So I am starting from here and then I'm moving up to here. So this is I'm calling this face as an end face. Fine. Now another is if we talk about this is the shaft. Okay, this is the shaft, and if we will mount the single point cutting tool like this. Okay, then either what I have to do is either I should mount in this direction, so I should move like that. Please try please focus here, that either I can move like this in this direction, or what can I do is if I'm mounting in this direction, then I can move like this. Okay, so either this should be the side I have to consider, or this should be side I have to consider. Any one of these side I have to use. Okay, so what I'm considering, that I will hold this single point cutting tool like this, and I will move in this direction. Means this is rotating and I will move in this direction. So cutting edge should be in this direction, right? And in this direction. Now, so this is the side. This is the side that I'm considering. Okay, so this is I just written over there S. Okay, this is S side and this is and. Now, okay, let's assume that this is a billet. This is our single point cutting tool. And okay, so this is the machine. This is the shaft. Okay, and when I will move in this direction, will there be a metal removal? Obviously little amount of the material removal will be there, because if this is the work piece, because it has a very low strength as comparatively with the tool, so when this tool will move in this direction, definitely there will be a removal of the material. But when I'm talking about I'm talking about when this is a flat surface, if you will see, then this is a flat surface, this is a flat surface also, right? Also, like if we'll go for a facing operation, then this is the turning, as I mentioned in the last class, that this is the turning and this is a facing when we are moving towards the center. Let me take my water bottle so it would be okay. So this is the turning. In this direction I'm moving, and toward this side when I'm moving, so this face will come in contact with the material, this workpiece, and that will remove the material. Okay, so in a single point cutting tool we need to be edges both the sides. Means in this side as well, in this end side as well. sorry, end side as well as in the side face. Okay, so this side I'm considering that we will move in this direction, so that's why I'm considering this as a side, and we will move in this direction to go for a facing operation, so that will be end face, right? Now just try to assume that this is a tool, this is the bloom only, and this is the tool. Okay, so when you will bring the, like, this is the thickness that you have taken into consideration initially. So when this tool, this side face, like, we have to go for a turning operation, means in this direction we have to move. So if this is the single point cutting tool, then what will happen that this, when you will move in this direction, give the initial depth of cut like that, and when you will move in this direction, the complete surface of this workpiece will come in contact with the surface of the tool. There will be removal of the material, but large forces is required, because this is not the cutting edge, this is a surface, right? Similarly, this is the end face. When you will go for, when you will give the initial depth of cut, like this is, initially it is here, and when you will give depth of cut, it will move in this direction. Okay, so now complete this face is coming in contact with this periphery, right? So what will happen, there will be a removal of the material as you will rotate, but large forces is required to hold this tool as well as to hold this workpiece, right? Because now the edge is not coming in contact. If I simply take an example of Caesar, okay, if we take an example of the Caesar, then when whatever the two cross sectional areas in which some paper is cutting, we are cutting the paper, the edges is there, it's not a flat surface. Whatever from the area, from the cross sectional area, this paper is cutted out, so that has the edges, they do not have the surface. The surface is there, but this surface is some, has some inclination angle, right? So what we have to do, if we have to make the turning operation, like if we have to move in this direction, then what we have to do, we have to make edge over here, right? And similarly, if we have to go for a facing operation, then we have to create an edge over here, right, in this end portion. So what I'm doing is, this is the end portion, guys, please see the side, this is the end and this is side. Okay, so what I'm doing is, I'm considering this as a point, I'm considering this as a point, and I'm just removing the material like that. Means from here, I'm just, whatever the material below this line, throughout the surface, throughout the thickness, okay, that will be, that I'm removing. Also, what I'm doing is, I'm just, as I have to make the edge in this side as well. So what I'm doing is, okay, I am removing this material. Means whatever the material below this edge, below this portion, below this red portion we are removing, and in this side we are removing this much amount of the material, right? So let me take this so what I'm doing is, I'm just keeping this cutter over here, okay, and I'm removing this material. Fine, this is throughout the thickness I'm removing, right? So when I will remove this material, guys, you should also have to perform similar exercise. Better it would, you will perform this exercise at home, otherwise you have to perform on the examination, final examination. So this is okay, so this is actually the our billet was there. Now I just kept the cutter over here, okay, over here, and I have removed this area. Means remove this area throughout the length, so please look at here, like this. Fine, so this is the side, right? Now from end also we have to remove, because for facing also we have to create the edge, right? So what I'm doing is, I'm keeping this cutter like this, okay, like this, and I'm cut, okay, and then I'm cutting throughout the thickness. Okay, so when you will cut it at the throughout the thickness, okay, so this is, was the actually, I kept the tool over here and this surface has been removed, right? This is removed. Fine, so now let's go for a machining operation. So when you will go for a machining operation, now when you will give the depth of cut, you will hold like this, okay, and give the depth of cut and you will move in this direction. Now please look at here that initially this was the surface. Initially, this was the surface which is coming in contact with the which was coming in contact with the workpiece material, right? Now you have to make the edge, you have cut it out the surface at some inclination angle. So now this tool is looks like that. But again, when you as you have removed this material throughout the width, throughout the sorry thickness, then now when you will give the depth of cut and will you move in this direction, now there is another surface is created. This is not created the edge, you have created the surface, right? So please look at here. Here I am defining two angle. We'll create the edge, but before going to that, I just want to define two angles. So initially this was your billet. Okay, so when you will see from the front view, like from this view, then this will be looks like that. Okay, now this is the side I'm considering, and this is end portion I'm considering, right? So what I have kept that at some angle I have removed this area, and from this end also I have cut some angle. Okay, so this angle when you will measure, because this was the side, this was the side. Now when you will measure this angle from this one, now, when you will measure this angle from this, now can you see this angle? Because after when I will completely prepare this single point cutting tool, this will not be visible. That's why. So this is the angle. You can see that this angle from this plane to this edge. Okay, there is some angle is there. You can see this angle. This one angle I'm talking about, right? So this is we call it as a side cutting edge angle, because through the side only we have removed, and why we created to make the cutting edge. Okay, so this is the side cutting edge, right? Cutting edge angle, and this is the end portion was there. This is the end plane. Okay, now the end plane is not looking, but this was the end plane. So when you will see this angle, this horizontal with the horizontal this much angle. Okay, so this angle we call this angle as a, can you see that? So this angle we call it as a end cutting edge angle. Okay, so when you will see into this one, so this angle is basically we are defining by the CS, that is side cutting edge angle, and this angle we are defining through the end cutting edge. So this is CE, that is end cutting edge angle. Okay, by the way, I will write these what these terminology are, but I just writing for here. This is CS, this is side cutting edge angle. Okay, and this is CE, that is end cutting edge angle. Okay, this is end cutting edge angle. Now will your tool our tool will be looks like this. Okay, when you will see from this shape. Okay, when you will see from this side, it will looks like that. Okay, now what we have to do is, what was our actually planning, we have to create the edge over here, but this is not a edge is created, this is like the surface is created. So what we have to do, we have to we have to create the edge. Okay, and what we are doing is when the machining is going on, we are keeping this portion at the top, this portion at the bottom. Okay, so this is I'm just writing over here that this is the top, this is T, this is T, and this is B, that is bottom. Okay, this is bottom, right? So this is top and this is bottom. So top means will hold the tool like this, means top position will be in this like this. Okay, so this is horizontally. Okay, so we'll move in this direction. Now if we are keeping this portion at the top, it means that cutting edge should come over there, means on behalf yahan, means where we have to place the cutting edge, here or here. So we are holding the tool like that, it means that over the top we have to create the edge. So how we will create the edge, how we can create the edge, when like if this is whatever the surface, like I have to hold the knife like this. Okay, and whatever the excessive amount of material, means at some incline I have to remove the material. Okay, at some inclination I have to remove the material. If I will remove the material below this edge, okay, and at some inclination, then this material will be removed, like I will remove this material. And similarly we have to create the edge over this end portion. So we have to see like this. Okay, means initially I was keeping the tool like this. Initially I was keeping the tool like this, means it not at some inclination but straightforward, but now I will tilt this angle. Okay, now I will tilt this angle. Initially I kept like this, but now I have tilted like that. Okay, so what will happen, this edge will be, I will take the reference of this edge, and I will take, remove this some amount of material below this edge. Okay, so that I'm doing. So first I'm removing from the side one, then I will remove from the end portion. Okay, so this is, can you see that I'm keeping this, this is the top portion. Okay, and I remove from the side. So can you see that this is initially at the top, there is a very small thickness is there. At the bottom it is this thick, the thickness of this whatever the material has been removed is increasing. So this surface will be looks like that. Okay, so this is, I'm removing this amount of material. Okay, this is done. Now similarly I am keeping this tool over here, and initially I was thinking to plan, when I remove this material I planned like this, but now I'm keeping at some angle, okay, to create the edge. Okay guys, so this is the end portion. This is the end portion. So this is initially the bot, if you will see at the top, which is the thickness of this material removed is very small, and bottom is large. Okay, so now what is, we have created that. Now when you will see this angle, when you will see this surface, it's from this basically. When you will see from this one, like this will be looks like a edge. Okay, so now you can move in this direction to remove the material, because only this surface will come in contact with this edge is come in contact with this material. Okay, if we have to go for a facing operation, then we can move in this direction. Okay, so only this edge will come in contact. But is we are moving in this direction, is we are moving in this direction, right? So okay, here one more thing is there, that how you see the end cutting edge angle, like this was the end surface. Okay, end plane, here you kept like that, and this is the angle, that is end cutting edge angle. But now in this plane only, like in this plane only, when you will see, this is the plane. So can you see this angle, little angle is there from this plane, this angle is visible, this angle I'm talking about. Okay, so this angle, so when you will see this angle is created, it means that this is the end clearance angle. Because to provide, because initially if we were not provide supposed to provide this clearance, then the material, when this material was complete material of this surface was coming in contact with the workpiece. Okay, so to provide the clearance, or to provide the material that can be easily removed from the workpiece area, as well as and that edge is created, so for that we have removed this material. So that's why we call it as a clearance angle. Whatever the angle that is created in this side, we call this angle as a side clearance angle, and from this end portion, whatever the angle that we created, we call this angle as a end clearance angle. Okay, so if you will see the geometry. Okay, so if you will see the geometry, then this is like from the perpendicular, from the normal. Okay, this angle. Okay, this angle we call this as a CE. Okay, sorry, not CE. This is gamma E. Okay, this is gamma E. Now this, what is this gamma E is? Gamma E is and clearance angle. And clearance angle, or sometimes we also call it as a and relief angle. And relief angle, that we have mentioned in we discuss in the that basic terminology part, right? So this is means clearance is like it is providing some kind of relief to the workpiece as well as tool. So that's why we are calling it as a relief angle. Okay. Now, if you want to see this side clearance angle, then it will not be visible. Okay, in this condition it will not be visible, it will be visible, but let me finish first these two angles. So now when you will hold the tool like this, workpiece like this, and tool like this. Okay, so now when we'll fold like this, then when this chip will be coming out, chip where from the chip is coming out, workpiece area. So this is the workpiece area, and like this the material is, it is rotating like this, is it is rotating like this, and this tool is coming in contact with this one. So this chip will come like this and go like this. Okay, so this is the tool. Okay, now when this tool will move, sorry, this chip is coming out, now this chip will be falling over this surface, over the top surface. Okay, so over the top surface it will fallen, and it will be fallen in random direction. It can be go in any direction. So what we have to do is, if it will move in any random direction over this surface, because there is no specific area we have provided that that will allow these chips to easy flow. So these chips will flow here and there over this surface. Okay, so and this chip, we have already seen that it has a high temperature, and because of that only the sticking takes place. So is it has a high temperature and it will move in any random direction over this face, then it will damage the surface of this tool, right? So what we have to do, that it should move in a specific direction, means the as the chip is coming out from this point, as the chip is coming out from this point, it should move backward. Please listen, it should move backward. Okay, so what we have to do, we are creating a it we are keeping the tool can you see this, this is parallel. Okay, so now I am keeping the tool, this cutting like cutter like that, and I'm just removing some at some inclination. I'm removing some amount of the material at some inclination. Because of that, whatever the chip is coming out at this top, at this point, that will be easily move in a backward side. Please listen, backward side. Okay, so that's what I'm doing. Okay, guys. So this is I'm keeping this tool over here. Okay, and I'm moving it some inclination. So this much amount of the material is removed, right? So now whatever the chip will be fallen over here, over this face, it will move in backward direction. Whatever the chip is fallen over this surface, it will fallen. It will move in backward direction, because now we have provided some inclination, right? Now we call this as a, we call this angle, can you see that with this horizontal, this angle is formed. Now this inclination angle. Okay, so this inclination is angle is created to move the chip to the backward direction, towards the backward direction. So we call this angle. Now when you will see from the horizontal, this angle is created. So this angle we call this as a alpha b, and this alpha b is nothing but that is a back rack angle. Back rack angle. Okay. Now there is a one more thing. There is one more thing, that is chip will be fallen over here. Okay, it will move in this direction, right? Now is this is the shaft. Okay, and we are moving in this direction, right? Now we are moving in this direction. Whatever the chip is coming out, this is falling over this 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 portion. Okay, this portion, this is falling over this portion, right? So this red color, you can see that this is the chips, you can just assume. Okay, now that is coming towards the back side. Okay, towards the, from here it is falling and it is coming towards the back side. Now either it can move in this direction, okay, or either it can move in this direction, right? So if it what we it will because this, if you will see this area which is very, if you will give some depth of cut, then this area, whatever the area is remaining over the single point cutting tool, is very small. So what we have to do is, we have to define that whatever the chip is fallen over this rake face, it should be immediately removed from this area. It should be immediately removed from this surface area. If it will stick, it will stay for some time, then it will stick to the tool face, so that will create like defects, okay, and that will, because of that, the tool will weaken, okay. So what we have to do, that should be removed easily. So what we can do is, if we are moving in this direction, if we are holding like that and moving in this direction, then there is a two possibilities. Either whatever the chip is fallen over this face, it should be moved in this direction, or it should be moved in this direction, right? So if we are moving in this direction, then it would be better that if it should not, it should fall on backside, okay, it should fallen to the side, okay. So either we can make it like this side, or we can make it like this side. But if you will make, like, this is the angle, so if you will make like this, if we'll make like this, then this cutting edge will be this thickness of this workpiece will, this tool will become very small. So what we are doing is, we are keeping this tool cutter like this, and we are moving towards the back side, means towards the back side we are at, here we are making some angle, and we are moving toward the back side. Fine, so that's what I'm doing. Okay guys, so now what I'm doing is, I'm keeping the tool over here, okay, and I'm moving toward the back side at some inclination, okay. So when you will go some inclination, like, this is the material has been removed, right? So when you will see from the front side, when you will see from the front side, now I think you can see some angle is there. Okay, is it visible? Is it not visible? Hmm, I think, I hope now, now you can see. Okay, so this blue color is visible, it means that some angle is created, okay. Now this angle is created in the side, means through this side, whatever the chip is formed, fallen over this work, over this tool face, that will be first of all, that will move towards the back side, and as it will enter over here, it will move in this direction, okay. So whatever the chip is coming over this tool face, that will be immediately drawn out from the face area, okay. So if you will see this angle, then for this angle, basically we have now, like here, basically you can see that here we are keeping the this cutter, okay, and we are moving toward this side, back side, okay. So if you will see this geometry, if you will see this geometry, then here from top this thickness is measured, okay, and from back side this thickness is measured. So this thickness is increased, okay. So if you want to see, if you want to see these two angle, like this is the back rack angle, okay, this is the, sorry, side rack angle, and one more angle is still there that we have not seen, that is side clearance angle. So for that, what we have to do is, we have to move in a third quadrant, because whatever we have seen, because civil engineering students are well aware about that, whatever we have seen, that was in first quadrant. But if we want to see these two angles, then we have to move in a third quadrant, okay. So if we have to move in a third quadrant, then what we can do is, we were looking from this side, means from this side you were watching this one. So now we can move, shift in this direction. But when you will shift in this direction to watch these two angles, if you will move towards this side in towards these two angles, then this surface will come in front, okay. So what we can do is, this will not be visible. So what we have to do, we have to remove this, we have to, like, what I have to do, I have to cut like this, okay. So this is the last view of this angle, okay, because if I will remove like this, then this angle will not, this tool will not be attached again, okay. So please, if you have any doubt, you can ask me, guys, okay. After that, after this, will it will not be like a single point cutting tool. So now what I have done is, I kept the tool over here, this cutter, okay, and I have removed this material, like these two portion has been removed, okay. So now if I have removed this area, it means that now we have shifted to the third quadrant, okay. So now how we will see this angle? So like I'm holding like this, and from the horizontal, can you see this angle? By the way, there is some very small angle is there. So this angle, you can see this angle. This angle is basically the side rake angle, okay, because on the plane surface we have created this angle. Can you see that? This angle, very small angle, okay, this angle here, this angle. So this angle is basically the side clearance angle. Fine guys, now I cannot attach this, for that I need the feviquick. So but this is a single point cutting tool geometry, fine. So I hope इससे पहले आप पहले भी आपको कभी थर्ड क्वाड्रेंट समझ में आया होगा. Okay, so this is the horizontal, okay, and this is the with the horizontal we have created this angle. So this is a side rake angle, okay. Sorry, yeah, side rake angle. And with respect to the perpendicular or this vertical plane, this angle is created. So this is the gamma s, okay. This is side clearance angle. This is side clearance angle, or side relief angle. Side relief angle, or this is the side rake angle. Okay, so if we'll draw the two-dimensional, if we draw the 2D views, then what it will looks like. First, front. Uh, okay, so first is where is my tool? Okay, this is here. So okay, so this is basically the front view. Okay, so from here, when you will see, this is the front view, okay, and this is the top view. So for this it will look like this, okay. And from side, because two angles that we have seen, for that only we have removed. So two angle we have seen, that is from the side. So actually that was not visible from this side, so we have to move in this direction, but still it is not visible. So for that we remove this material. So now this is the two angles, okay. So front view, if I'm talking about the front view, then how many angles is visible? That this is, this angle is visible, okay, that is a back rake angle. And this is the when I'm looking for this one, then this angle is visible, right? So this is the back rake angle, this is side and clearance angle. When you will see from the top view, this from this side, this is the side view, means side cutting edge angle. This is end cutting edge angle. And when you will see from this view, then with the horizontal, this is a side rake angle, and this is a side clearance angle, right? So if we talk about the front view, then front view will be looks like this. Okay, so actually it is we basically we created up to this one, like it's some angle only. But if we want to create some incline, some curve portion, that also we can create, okay. So there is no issue. So this is the top front view. When you will see the top view, this is the top view. And when you will see the side view, okay, so this is the back rake angle, this is alpha b, okay. From front, from this view, this is the side cutting edge angle, that is CE, okay. Sorry, this is the clearance angle, not cutting edge angle, this is gamma E, that is end clearance angle. Okay, from end this edge is visible, so this angle is CE, that is end clearance angle. Okay, and sorry, end cutting edge angle. Sorry. This is end cutting edge angle, and this is side cutting edge angle. This is CS. Okay. From the horizontal, when you will see this one, the side view, that is alpha S, that is side rake angle, and this angle which is remaining, that is gamma S, that is side clearance angle. Okay, guys. Now, as I said that we moved to see this one, that is in the third quadrant. So what we have to do, because this drawing we are making in the first quadrant, so what we have to do, we have to make these lines. This is very very important, guys. Okay, so this is these lines we have created, so this is, it means that that is in a third quadrant. Okay, so this is the 2D view of a single point cutting tool. Now let's move, guys. If you have any doubt, you can ask me. I can wait for 1 minute, then we'll move to these tool signatures. No question? I hope no one is sleeping. Okay, so let's move to the tool signatures. Okay, so tool signature is nothing but the it defines the how we are basically keeping the tools, or how we are basically machining the tools. Okay, so if we are like whenever some like is the scientists or research organizations are continuously working to invent new materials. So if like for the working purpose, okay, so if they are creating the workpiece, new material for the workpiece, then definitely it needs, let me, okay, so definitely it needs the new tool material as well, right? If it is uh, achievable, but whatever the tools are available, then it's okay. But if we have to create the new material for the tool, that we have to modify it. Okay, so if we are modifying, for an example, if we are new material is created for the tool, then there will be a different angles are there that we have seen, that is back rake angle, clearance angle, and the cutting edge angle. So these angle we have to create. Okay, so if we are creating these angles, then worker is there. Okay, those who are machining these things. Okay, engineer will not go to there. So if worker is doing, then he or she, they know only about the in which language you are giving them that what angle we have to create. Like as I created this thing, this model. Okay, the similarly if you are creating, then you will keep in mind that how much there is a side angle, side cutting edge angle, how much there is a side clearance angle, how much is back rank angle we have to create. So if you will see the American Standard Association, that is ASA system, if we define the ASA system, then it follows the code like alpha B, alpha S, that is back rake angle, side rake angle, and that is gamma E, that is end clearance angle. Okay, gamma S, that is side clearance angle. CE, that is end uh, cutting edge angle. CS, that is side cutting edge angle, and R. Okay, so if we talk about the tool signatures, then these tool signatures is represented like this. Okay, there are total 7 quantities. First 6 quantities are defined as the angles. So that is in degree. That is in degree, and this R is nothing but the nose radius. The nose radius. Okay, now similarly it's like how the nose the radius is at our nose, because if you will see this point, this point is will be end. So if this is very small, if this tip is very small, and as it will give the depth of cut, so this tip will come regularly come in contact with the workpiece material if we are going for a facing or the turning purpose. Okay, then what we have to do, if it is very small, okay, very small like 0 mm thick radius, okay, means sharp, we can say it is very sharp, then there is a chances to remove this material, this will become like at some radius. Okay, means the sharpness will be removed very easily. Okay, so what we are doing is we are making some radius over there. Okay, so exactly we are not like if we talk about this point, this point, okay, then it will not be as sharp, it will be like a circular in shape, means some radius we are providing. So this radius we are calling it as a nose radius. Okay, so this nose radius is always measured in either in mm or inches. If we'll go through the foreign books, then that is mentioned in the inches, and Indian authors that is mentioned in the mm. So please keep in mind that if there is a tool signature is mentioned, then there will be a total 7 quantities will be mentioned there. First 6 are the angles, and next last one is basically the nose radius. Fine, and that unit is also different for both. Fine. Now if we talk about the orthogonal rake system, then the single point making of the single point cutting tool by using these figures was easy. By using these terminology like back rake angle, side rake angle, clearance angle, uh, cutting edge angle, it was easy. But for orthogonal system, it's typical. So that's why I'm just using the parameters only, that what parameters in which basically the tool signature is used. Okay. So first is, by the way, I will tell you that what is difference between ASA and ORS. Fine. So here, if we are talking about the ORS system, that how to write these angles, okay, this how to write the tool signature. Then first is basically the I, that is inclination angle. Then it is alpha O, that is orthogonal rake angle. Then it is gamma O, that is orthogonal cutting edge angle. Okay, sorry, clearance angle and orthogonal clearance angle. Then gamma A, that is auxiliary clearance angle. Okay. Then it is CA, that is auxiliary cutting edge angle, and then it is a lambda, which is the approach angle or the principal cutting edge angle. Then it is a nose radius. What the meaning is, and I will also write what these are basically. I is basically the inclination angle. I is basically the inclination angle. Alpha O is basically the orthogonal rake angle. Okay. Gamma O is basically the orthogonal clearance angle. Gamma A is the auxiliary clearance angle. Okay. CA is auxiliary cutting edge angle. Okay. And last is lambda, which is we call it as a principal cutting edge angle. Sorry. Principal cutting edge angle. Okay. We also call it as a approach angle. Okay. And ours is the same, that is nose radius. Now, let's take a simple example or these images that I have prepared for you guys in the SolidWorks. So this is the simple billet. Okay, this is a simple billet, and we are considering that this is the end portion and this is the front portion. So we are creating all these things, this complete geometry over this side. Okay, and this is the end as well as this is the end portion, as we are considering that this is a side. Okay, so what we are doing is we are taking this some angle at some inclination. We have removed this material, but now another surface is formed. Okay, and similarly in this side we kept like this, and we have removed the material which is below to the surface. Okay, so this new surface is created at some inclination angle. Okay, now what we are doing is in this in this one. Okay, below this, over this, basically I'm keeping the tool at some the knife at some inclination angle, so that has been material below this is removed. Okay, so that you can see. Okay, similarly after doing this, I'm keeping at some inclined toward this side, so some amount of material is removed from this side, so this is the side cutting edge angle. Now when you will see from the top view is the chip is coming over this surface, so we want that it should move backward side, so back rake angle we have created, right? Here is we want that two these chips either should move toward this side or toward this side when it is fallen to the rake face. Okay, so what we have created that initially in this side we are keeping the uh, a small thickness, and back side we are keeping a large thickness, so that side rake angle is provided. Okay, and this is the final geometry. So this is just the SolidWorks images. Now when you will see when we talk about these ASA system, so if you will see okay, so if you will see in the this is just a this is also a SolidWorks image. So I just want to show you the ASA, that is what angles we use there. So if we talk about the SolidWorks, then here it's mentioned that that is a top plane, front plane, and the right plane. But here we are not using this terminology. Here we are using, for ASA system, we are using the base plane. The base plane. Second is basically the longitudinal plane. The longitudinal plane, and third one is basically the lateral or transverse plane, we can say transverse plane. Okay, so if we talk about this one, then this is do not consider this top, front, and the side right plane. Just consider that this is the plane. Okay, this is the plane, base plane, in which basically we kept this single point cutting tool. Okay, so this is the base plane. So here that this plane basically in which this single point cutting tool is kept, so we call this plane as a base plane, right? Now whatever the plane, if I am considering like this transfer plane and the longitudinal plane, that depends on what axis we are using. So if I am considering this as a axis, if I am considering this as an axis, then all of you are aware about that this is a longitudinal axis. It means that whatever the plane is along this axis, we call this as a longitudinal plane, and perpendicular to that, that would be a transverse plane. So here you can see this right plane here is basically the longitudinal plane. This is a longitudinal plane. Okay, and front plane here, which is perpendicular to this longitudinal, we call this as a transverse plane. Transverse plane. Okay, now when you will see from the top view, okay, so this from this angle you can see this is the side cutting edge angle. From the front, when you will see, this is the end cutting edge angle. And similarly, like we can measure these different angles that we have gone through. Okay, if we talk about the ORS system, if we talk about the ORS system, then if we talk about the ORS system, then what has happened that this tool is in same, that is in the base plane only. So this is the base plane is same. What we have done, this right plane or this longitudinal plane, it was like in this along with this direction, right? Along with this direction. But now whatever the edge, that side edge, side surface, we have cut it some angle. So in this plane only, in this plane only, in this edge only, or in this surface only, we have tilted that angle. We have tilted that angle. Okay, so we are calling it as a either, if we are talking about the ORS system, if we are talking about the ORS system, then we call it as a cutting plane, or this is a auxiliary plane, and perpendicular to that, this was the longitudinal, and that is perpendicular to that, that is transverse. But is you have tilted at some angle, so this is the auxiliary plane, and perpendicular to that, this is a orthogonal plane. Orthogonal plane, it means it was very simple. It is very simple, like this is the tool. uh, it means that this is the tool, and we kept the uh, we kept the face like this. We kept the this is basically the longitudinal plane in the ORS ASS system. But now we have tilted this angle. Okay, we have tilted this plane, so we are defining this plane as a auxiliary plane or cutting plane, because in this plane only, because this is the cutting edge, and because of that only the material will be removed. Okay, so we are defining it as a auxiliary plane, and perpendicular to that, this angle is like this, then this this another plane will be like perpendicular to that. So that is basically the orthogonal plane, like that. Okay, so now what we are doing is there is two things. Okay, two things is, if incline there in an orthogonal system, I written that first angle, that is I, that is inclination angle. So what is the meaning of that? Still, like, if we are like, if I'm using this, can you see like that? Okay, so now this is actually, this was the plane longitudinal. Now we have tilted it some angle. Okay, now if I'm using, if I'm keeping the single point cutting tool like this, initially it is like that in the plane, base plane, and now if I'm tilting, it's like that only, that how we are cutting the onion or potatoes in the kitchen. If we are not going like this, we are keeping at some angle. So what we are doing is, basically we are tilting the tool in the kitchen. Tool is what? The knife only, and the workpiece is what? Onion and the potatoes. So we are keeping at some angle, right? So if we are removing its if we are removing some angle, it means that there is some inclination we have provided. And if we have provided this inclination angle, then we call it as a oblique cutting. If this inclination angle is not provided, and that is perpendicular to that only, perpendicular to the face, okay, perpendicular to this auxiliary plane or cutting plane, then this inclination angle is zero. It is like that. Okay, this angle, you can see that this angle is zero. Now at some angle is there. So this is a oblique cutting, and this is the orthogonal cutting. So if we are talking about the ORS system, if we are talking about the ORS system here, if we are talking about the ORS system, means inclination angle, then this inclination angle will be equals to 0 for the orthogonal cutting. For the orthogonal cutting. And if it is a oblique cutting, means this I will not be equals to 0. This is a oblique cutting. We call this as a oblique cutting. Fine. Now the angle which is measured with this orthogonal plane, okay, over the tool face. Sorry. Okay, so over this is the orthogonal plane, and with respect to that, means if this angle is like that and we are measuring like that, this is in this direction we are measuring at some angle. So this is the orthogonal. This is the orthogonal rake angle, right? This is the gamma naught, that is clearance angle, orthogonal clearance angle. This is gamma A, that is with the auxiliary plane we are measuring. So this is the auxiliary clearance angle. This is CA, which is the auxiliary cutting edge angle. This is lambda, which is the approach angle. Now this, why we are calling it as the approach angle, there is a one more figure is there, that initially we kept this is a longitudinal plane. Okay, and if we are talking about the auxiliary plane, then we have tilted this angle, tilted this plane in this direction, right? So if we have tilted this angle, this is now auxiliary yeah, this is now a auxiliary plane. So this, the plane angle which is from inside, this angle, we call this as a lambda, that is the principal cutting edge angle. Means now initially the CS we were measuring through this one, through the longitudinal plane to the cutting edge, but lambda we are measuring from the inside, from the horizontal. Okay, so this is lambda. So if we want to define the relationship between lambda and the CS, then this is total angle will be equals to 90 degree. This CS plus lambda is equals to 90 degrees. So lambda, you can get it the value of lambda, that is 90 minus CS. So whatever the angle CS, side cutting edge angle that you kept in the ASS system, 90 minus that will be equals to the approach angle that is in the ORS system. Okay, or the principal cutting edge angle you can consider. And R is nothing but the nose radius. R is nothing but the nose radius, and that is again calculated in the mm and inches. So these are the two terminology, that is two types of the tool signatures that is mentioned in the standard book. Okay, normal rake system, that is no need to mention whatever we have discussed, that orthogonal cutting I equal to 0, that time you can consider that is a orthogonal cutting. I is not equal to 0, oblique cutting. So this is only mentioned when I equals to 0, that is a normal rake system. Okay, so there is no need to mention that one separately. So whenever if this question will be there, that how many types of the tool signature, mention two type only. Okay, American and the ORS. Fine. SA and the ORS system. And again, if you will see in this ORS system, there is also total 6 angle 2, 4, 6. Okay, these are calculated in the degree. Okay, and nose radius, that is R, is calculated in the mm or inches. Fine. So guys, this is all from my side. If you have any doubt, you can ask.